So welcome back, and in the last class we were seeing about one of the operations, that is advancement and shifting of a signal, advancement and delaying of a signal, that is shifting a signal to the right or left. Okay, and this we discussed in the earlier class. That is, if I am subtracting t with capital T, I am shifting the signal to the right, whereas if it is if this is positive, or I can make it in the other sense, that is, if t is positive, then I'm shifting to the right, and if t is negative, I'm shifting to the left. Okay, and that's very simple. Just to know the starting point of a signal, just you want to uh, put the argument t minus capital T equal to 0. So if you do that, then the signal starts at capital T. Here also, if you put the argument to 0, the signal starts at t is equal to minus t. So this is where the signal starts. Okay, so same argument can be set for discrete signals also. So if we have y of n is equal to x of n minus k, you are shifting the signal to the right by k units or k samples. Okay, so if k is positive, you are shifting to the right, and if k is negative, then you are shifting to the left. Okay, and I just show you an example. That is, this is my x of n. If I want to know what is x of n minus 3, then I just want to know which is the starting point of my signal. What is my starting point of my signal? That is n minus 3 is equal to 0. That is n is equal to 3. So the whole signal now starts at n is equal to 3 rather than n is equal to 0. Okay. Likewise, if I want to this signal, and if I have the signal and I just want to know what is x of n plus 2, then just put the argument is equal to 0. That is n plus 2 is equal to 0. That is n is equal to minus 2. So the signal, rather than starting from n is equal to 0, it starts at n is equal to minus 2. Okay, so this is the whole thing. Okay, simply put the argument to 0 and just know which is the starting point. If you know the or if you get the starting point, very easy to plot the signal thereafter. Okay, that is one thing. And next important operation is the time reversal. Okay, reversal of time. Okay, here you can see that for all other discussions we have x of t. Okay, what if it is x of minus t? That is, we are flipping x of t and x of minus t are more or less the same, but thing is that we are flipping the signal around the reference point, that is t is equal to 0. We are flipping the signal, or x of minus t is just the reflection of x of t, or we are flipping the signal around t is equal to 0. I'll just show an example. By seeing the figure, it will be more clear. That is, this is my x of t and this is my x of minus t. The same signal is flipped over around 0. This is my reference. Okay, that means what is happening at 4 will happen at minus 4, what is happening at 3 will happen at minus 3, what is happening at 2 will happen at minus 2, and what is happening at 1 will happen at minus 1. Just flipping the signal around the reference point 0. Now we can actually advance or delay the signal by some seconds. Suppose if you want to have, you have the signal x of minus t. If you want to perform x of minus t plus 3, then what is the starting point of that signal? Remember, this is the starting point of the signal. Okay, this is my reference point. Reference point is always a starting point. If this is my signal which I have to plot, then just equate the argument to 0. So what condition? That is minus t plus 3 is equal to 0. That is minus t is equal to minus 3. That is t is equal to 3. So the signal starts at, here the signal started at 0, now the signal starts at 3. Okay, similarly, if we have x of minus t here, and if you want to know what is x of minus t minus 3, then simply put the argument to 0. Then you can say that t is equal to minus 3. At that point the waveform starts. Okay, now next one is okay, this is another example. You can just go through that. Now the same thing happens here also. That is for discrete time signal. That is x of n is here, and what is x of minus n? That is same argument, flipping the signal around 0. That is 0, what is happening at 0 will happen at 0 itself for x of minus n also. That is at 0 it is 4, at 0, so minus 0 and 0 are the same thing. Okay, and what is happening at 1 will happen at minus 1, what is happening at 2 will happen at minus 2, what is happening at 3 will happen at minus 3. Likewise it goes. Okay, Now from here you can find what is, if you have x of minus n, you can find what is x of minus n plus 3, and if you have x of minus n, you can just see what is x of minus n minus 3. Just take this example. What is x of n minus x of minus n minus 3? It starts at n is equal to minus 3. So this signal starts at n is equal to 0. Now this signal x of n minus 3 starts at n is equal to minus 3. Okay, so that is the time reversal. Okay, very important operation, and that will come into picture when we learn about convolution. Okay, so these are some examples. You have to sketch those signals. I'll just show the second, that is first two examples, that is u of minus t plus 2, the first one. Okay, so you have to plot what is u of minus t plus 2. So first you have to know what is u of t. U of t, you know, it's all 1 from t greater than or equal to 0 till plus infinity. Okay, it's a purely right-sided sequence. And what is u of minus t? Just flipping the signal u of t around 0. So this is the thing, u of minus t. And what is u of minus t plus 2? This signal starts at a point when the argument is equated to 0, that is minus t plus 2 is equal to 0, that is minus t is equal to minus 2, that is t is equal to 2. So this signal starts at 2 here. Now the signal is, that is u of minus t plus 2 is this one. Okay, now so that is the signal that we have to plot. Similarly, you can actually plot what is minus 2 u of t plus 2. So from that also the starting point is u of t. So if we have u of t, then you can easily plot u of t plus 2. What is u of 2 plus 2? T plus 2. It starts at a point t is equal to minus 2. So this u of t starts at a point minus 2, that is u of t plus 2. That signal is multiplied by a multiplication factor minus 2. So from minus 2 till plus infinity, it continues to plus infinity. It's all 1. That signal is being multiplied by minus 2. So what happens? All 1 multiplied by minus 2 will get what? Instead of 1 magnitude, we have minus 2 magnitude from minus 2 till plus infinity. Okay, likewise you can sketch the other examples also. Now I'll just move on to the next operation, that is okay, so move on to the next operation. Next operation is that we have two type of scaling. One is amplitude scaling and the other is time scaling. We'll first see what is amplitude scaling. Okay, amplitude scaling is very simple, and that is just we have seen one, that is if this is x of t, if I multiply my x of t with a scalar, that is some constant, that is here I am multiplying with 2, what happens? The amplitude increases twice. Okay, rather if I multiply this with a scalar which is less than 1, what happens? The amplitude reduces. So if the scalar quantity is greater than 1, that results in amplification, and if the scalar quantity that you are multiplying is less than 1, that becomes an attenuation. That is called amplitude scaling. Now here also for discrete also that remains the same, that is each sample value is multiplied by that scalar. That is at minus 1 you have 2, and for this operation at minus 1 instead of 2, your 2 is multiplied with 2, so it becomes 4. 1 becomes 2 and 2 becomes 4 here. So each sample is multiplied by that scalar. Okay, now next important operation is what is called time scaling. So what is time scaling? Time scaling is the sense, instead of multiplying the whole signal by a scalar, the scalar is being multiplied by the time. The argument is time. The argument is being multiplied by the scalar quantity. Okay, so this quantity a can be greater than 1 or less than 1. Okay, now I'll show two examples. That is, I have an example here. That is x of t is like this, and what is the signal x of 2t, that is equal to y of t. Y of t is equal to x of 2t. Okay, just to know that, I just put the value of t as minus 1 here. So I want to just find what is y of minus 1. So if y of minus 1, t is equal to minus 1, if I substitute that here, it becomes x of minus 2. What is x of minus 2? This is my x of t. I don't have a value at t is equal to minus 2. So there is no value here. Then I'll take what? Minus 0.5. If I take that is y of minus 0.5. Then what happens? I'll get x of minus 1. I have a value at x of minus 1. At x of minus 1, I have a value 0. It's the starting point of my signal. So this point will come here. Okay. From that, so 0 remains 0. Y of 0 is equal to x of 0. So this point is here and this point is also here. Just join these 2 points. Likewise, if you continue like this, that is what is at x equal to 1. What is x equal to, for example, y of 1. What is y of 1? Y of 1 equal to x of 2. Y of 1 is equal to x of 2. What is x of 2? X of 2 is this point. So this continues till this point, that is at y of 1 I'll have x of 2, this value here. Okay, again if I substitute y of 2 here, if I substitute y of 2 here, then this becomes x of 4. X of 4 I don't have a value. If I substitute 1.5, what happens? That is, I have what 1.5 is nothing but 3 by 2. That is, I'll get x of 3. X of 3 is equal to 0. So at y of 1.5 I have 0 value. So you can see that when you compare these two signals, when you multiply the time by a scalar a which is greater than 1, I can see that the signal is being compressed. That's a very important conclusion. The signal is being compressed if the multiplying factor of t is greater than 1. What happens if the multiplying factor of time is less than 1? For example, if I have 1 by 2 being multiplied with t, you can see that the signal is being expanded. This is the same explanation you can see here also. So by multiplying the time by a scalar which is greater than 1, the signal you are compressing, and if you multiply the time by a scalar which is less than 1, you are expanding that signal. So this is basically an operation performed in DSP. Okay, compression of a signal and expansion of a signal. Okay, likewise you can have this for digital discrete time sequence. So if this is my x of n, then what is x of 2n? That is, for example, what is happening at n is equal to 0 will happen here also. Okay, now then what is x of, suppose if I want to have the value at suppose 1 here. What is happening at 1? So that is suppose I just want to know what is the value at 1 here. So if put n equal to 1, so that means x of 2. So x of 2 is nothing but 3 here. That's 3 is coming here. So at sample 1 I have 3 here. Okay, likewise if I just want to find what is happening at what is the value at n is equal to minus 1, just substitute it here. That is x of minus 2. What is x of minus 2? X of minus 2 is 3 here. Okay, you can continue this way to the other points. Okay, likewise you can see what is happening for x of n by 2 also. Okay, so this is the thing which is happening. Explanation is clearly given here. Okay, everything is here, just refer that. Already I have given the explanation. And next one is signal addition. Okay, what is signal addition? For suppose we have two signals, that is this is the two signals, that is this signal is being added with this signal is being added with this one. That is, if I suppose this part from this signal is being added with this signal, that is from 0 to 1 we have 2 here, and from 0 to 1 I am having this signal. Okay, so what happens? That is, this entire signal is added by a constant factor 2 here. So I am adding an offset here. So this complete signal rises by an offset 2, and from 1 to 3 it is all 1. From 1 to 3 here also it is all 1. So what happens? My result will be 1 plus 1, 2 till t is equal to 3. Likewise, here I am having this 2 here, and here I am having a decreasing function which is being added. So this decreasing function is offsetted by or increased by a factor 2. Okay, likewise if you perform the difference of x1 of 2 and x2 of 2, I get a result here like this. Okay, just see that result here. Okay, this is my reference. In the middle portion we have both ones. 1 minus 1 is 0. These two things you can just go through and understand. Okay, next we'll see what is signal multiplication, and afterwards we'll go to the basic operations performed on a signal. Thank you.